We are now recording, so anything you say can and will be shown in the YouTube video. I'd like to welcome everybody to the July joint meeting between the Shropshire and Novolug groups. Our meetup today is being presented by Tameika Reed from Women in Linux. Tameika is the founder of Women in Linux, which is a nonprofit based in Tampa, Florida, and it does what it says on the label. It's about getting women into Linux and open source in general, getting women more accepted and active in those communities and in IT in general, which I think is something that is desperately needed. They do a great job. In fact, I have supported them by buying my Women in Linux mug. I've got my Women in Linux t-shirt. I've got one for my wife. Any money you can donate, they will gladly accept. And they do have a Slack channel, which I will let Tameika talk about. But they are doing a world of good. The Slack channel is a great resource, and you don't have to be female to be accepted into their community. I have found it very welcoming in the past few weeks that I've been there, and it is absolutely a very welcoming and inclusive and awesome community. I really, really highly recommend everybody here join Women in Linux, and it is Women in Linux on all the platforms. Kenny asked, this mug is heavy. This has some weight to it. And it really, I drink cold drinks. I don't drink coffee. It will keep ice for almost 24 hours. So it is a really awesome mug. And 18 bucks, a bargain. And it's a cool purple color. So without further ado, it is my great pleasure to welcome Tameika Reed of Women in Linux. She will be talking to us about Terraform and more. So I will leave it up to you. People, if you, Tameika, are you happy with people breaking in, unmuting to ask questions, or
Yeah,
would you
yeah.
rather have them wait until you say any questions?
No, I prefer interactive meetups. That's how I run my meetups. I'm not sure how that works for you and your recording. However, I know I'm always the person in the room that has a question and I don't write it down and then I forget it and then I don't want to walk up to the mic to ask my question and I can just raise my hand or shout it out. So if you do have a question, please feel free. I'm going to be honest. I am not going to probably be looking at the chat. So if you have something, say it, or if somebody can moderate the chat
I
while
will
I am
I will
walking
watch
through.
chat. So anything that comes through on chat, I will relay on to you.
Got you.
In fact, the chats, I will wait until you ask a question, unless
Okay.
it relates to the topic you're talking about at the time.
Got you.
I try to
All right.
use common sense.
Oh, got you. No problem. All right.
Um,
As
I will turn it over to you now, and I will mute myself and turn off my camera.
got you. As stated earlier, I am Tameika Reed, founder of Women in Linux. You are correct. You can find us on social media, everything Women in Linux except for TikTok. I think we even have. I think we even have like a. I think I created a MySpace account. I think I did, but we don't use it, so it doesn't matter. As you can see, we have our Slack group there. One thing about us, I believe in of, of doing. So if you come to the Slack group and you have questions or you got something that you want to go over, post it. If you have an error or what have you, we meet every Wednesday, and our meetup is interactive. I literally go through and set up my screen and actually walk through the terminal. I don't even think I've in all the meetups that we have had over the past 4.5 years, I don't think I've ever had a GUI other than my laptop. So it's kind of like where I'm at. So if you're the hardcore Linux person, you probably enjoy it. If you're from the IRC era, uh, the gray beards and so forth, you'll probably fit right in. You'll probably love every last bit of it. Let me go forward here. All right, so today's topic, I'm gonna kind of go back and forth in between screens here, so you gotta forgive me. I've actually posted these slides in Slack. They are links, and the reason why some of them are links is because I really want to go over the content in those places and show you how they interact with some of the things that I want to show you today. So we're gonna go over some general Terraform stuff. I consider that kind of like housekeeping and hashy tools. But one of the main things I want people to take away is one, the demo and automation, and then how to study. And then Terraform Cloud kind of integrates with this. I'm trying to get to 2 demos if I can, if time allows me. So bear with me if you feel like you're being rushed through information or whatnot. I'm trying to save some time for questions and answers and so forth and so. All right, so let's get into it. All right, so I think everybody here is probably familiar with Hashi as a company. They are I don't want to say founders of Terraform, but they created Terraform, but they also created other tools as well, and these are listed here. So they created Terraform, Console, Vault, Packer, Vagrant, and Nomad. So Terraform, when you think of Terraform, think of, well, I don't want to say infrastructure as code because that's totally different. But when you're doing a comparison you probably should compare Terraform to CloudFormation in a sense. So let me explain that, and then we'll keep going. So with Terraform, there's no client or agent that needs to be installed, just the actual binary itself. And you can find that on Hashi's website. The major difference between Terraform and CloudFormation is Terraform can hold the state of your infrastructure. In other words, just as you mentioned earlier, you logged into your machine because you like to play around. Well, in theory, I get it, but in theory, we don't want to log into our machines. We want to, what we like to say, manage or orchestrate with our machines. But I get it if you're playing around. And then as far as CloudFormation is strictly used in AWS, and it doesn't hold state either. In other words, you don't query CloudFormation. You query actually AWS, but you don't that state is actually held by AWS per se, but you don't query and get the state of using CloudFormation. So that's one of the major differences. And the other one is when you're using Terraform, Terraform is agnostic to your platform. So that's the key major differences there. As far as console goes, I don't know how many have used console, but I've set up console in Terraform Enterprise, Console Enterprise, Vault Enterprise. And from the perspective of using console, we're talking about now we're getting into, how do I keep up with what services are out there? How do I monitor those services and the health of those without using, I don't want to say without using, but it uses internal DNS. So when you're setting up your console server, your console server and your console agents, you're typically going to set up your server, and it's always going to your servers is always going to be in a 3-node cluster at minimum. And then you're going to set up agents on that to monitor whatever services you have set up. With console as well too, you can get into more of a security feature from console using console intentions, where I can say, hey, I have a web server out here, and then I have a database over here. And well, say I have 5 web servers. Well, I only want these 2 web servers to have access to this database. And I want these 3 web servers to have access to that database over there. So you can use console intentions where you can get even granular with your security. To add to that security, instead of using username and password stored inside a file or a lookup table or something like that, you can manage that with Vault. So now you can query Vault for a username and password or some type of key or however you set up your authentication. But to add to that, let's say that you want a user to only be able to log into a server that you stood up for them to play in on some network, remote network somewhere, and you're going on vacation and you don't want that user to have access after, say, 30 minutes or 15 minutes, or you just want them to be able to log in, do what they got to do, and get out. You can utilize Vault for what we call one-time passwords. You can set it up for SSL certificates as well for intermediate, especially if you're building out web apps. And this really comes into play when we start talking about automation and infrastructure as code. If I have a web server out there that needs an SSL certificate, I don't want to have to go fill out a form and walk through and say, hey, yes, I completed these steps and now you give me an SSL cert. Then I have to wait 2 or 3 days. That's slowing down the process. So with Vault, you can set up an intermediate authority in order to take care of some, I don't want to call it menial tasks, but inside your cluster or inside your web servers or wherever else you would need your SSL certificates. I went over Terraform, Packer. So one key thing about Packer is you can use Packer to do a lot of things. So Packer can create your machine images for VMware. You can create machine images for Azure, AWS. You can create machine images for Azure, AWS, Google Cloud, and then the other tool is Vagrant. But what the one key thing I want to say about Packer is it's a very useful tool in terms of, hey, I want to get to the place where we're doing mutable infrastructure versus immutable infrastructure. You really want to be on immutable infrastructure. But when I say that, we want to get to the place where anytime I deploy something onto my network or onto my platform, I have done these things. And it's called, there's actually a tool out there called Shift Left, but we're actually shifting security left. But what I want to do is I want to, minimize any type of manipulation I have for that particular image that's getting pushed out to whatever platform you're using. So let's say AWS. We want to, 2, make sure that image has been hardened or meet the security standards of that company or whatever platform you're using. Somebody may need to be HIPAA compliant. Someone may need to be PCI compliant. Someone may need to be SOX compliant. Whatever the case may be, you want to push your images out in a secure fashion and in a controlled fashion, so you know again what you're deploying out to your actual infrastructure. And so using Console, Vault, Terraform, and Packer gives you that control. Vagrant, I find most people using Vagrant just to figure out locally how to set up their workflow, what it could look like. I've seen Vagrant deploy Terraform. I don't use Vagrant much because I'm always just building out images out in AWS and using Packer. So I'm not gonna say I'm not a Vagrant fan. I just don't use it every day. And Nomad, I have not used that, but it is a scheduler. And if you look at these links that I provided in here, so you can get an idea. One keynote about Console that I didn't go into was Service Mesh. I've seen people go back and forth with Service Mesh with Itch.io and Envoy. I think it's really depending on what you like for that. And they also have, under Hashi, they also have Console Connect. I'm not sure where that project is at because I don't hear a lot about it. I don't know if they decided to scale that back. I would have to look that up, and if somebody want to look that up while we're going through this, that'd be great. But I'm not sure where they're at with that project. I know it's out, but I'm not sure. I don't hear a lot about it anymore. Any questions so far? Cool. All right, so there's two versions of Terraform. When I say two versions, I mean there's one that's the open source version of Terraform, and the other one is the enterprise version of Terraform, which has a lot more to it. So I think everybody here is probably familiar with the open source version. Again, download the binary per their standard, throw it into your path. Usually user local bin is where most people, or from their documentation, where they drop most of their stuff at. Some people just throw it in their path, whether it's user bin, user S bin, or wherever you decide to place it at /opt, and then update your environment variable for your path for Terraform. So one of the big things about Terraform Enterprise, and we're going to get more into this, is the backing of Terraform Enterprise. Then this was a year ago, and so some of this has kind of changed. The back end of Terraform Enterprise, you had to install console first. You had to make sure it was up and running and everything was connected. Then you had to install Vault, and Vault had to see that console cluster, and then you would install what they used to call private Terraform Enterprise, and now it's just called Terraform Enterprise. It used to be called PTFE, now it's just called Terraform Enterprise. But with that being said, the backing of Terraform Enterprise is where you're going to consider and hold your state, where you're going to start looking at your multi-cloud strategy, where you're going to start to really try to scale your enterprise. Now, what I've seen mixed with Terraform Enterprise and Terraform itself, I've seen Terraform and then maybe Ansible Tower mixed in, Terraform Enterprise and Ansible Tower, and then some type of version control system, whether it's Bitbucket or Circle CI or Concourse or GitLab or what have you. That's usually the patterns that I'm seeing. And I think everybody here is probably a little familiar with Git. If not, I understand, but usually you're checking your code into some type of repository, and then from that repository, then you're creating something, or you're pushing, or something is pulling something somewhere. There's some kind of trigger there, depending on what you're using. So with Terraform, when we're looking at number 3 here, when we're talking about defining infrastructure as code, we're declaring, again, and I'm using that word on purpose, we want to declare our resources out onto a platform. In other words, I want my infrastructure to look a certain way. And how does that look? What does that look like? And so when we're talking about that full life cycle management, and I'll get into this now, and I'll probably end up skipping this slide. We're talking about a workflow for Terraform, where we're actually saying, write your actual, declare your infrastructure, write that down. And the way Hashi describes it is you plan, and then you write your plan, and then you apply. And I'll go over this a little later, because I think there's more steps that need to be taken into consideration when we're talking about using a workflow when we're talking about Terraform. So I went over Vault. Let's go over here. I'm gonna come out of this mode here, and I actually want to go over here to these use cases, because I think these use cases are super important. Never mind all my tabs. I am a tab person, so please forgive me. So here, I want to specify this right here, because there's Vault, and those who are familiar, there's Ansible Vault. And I won't get into the details of the differences on those, but I think if you don't use Ansible inside of your configuration, if you're using Puppet or something like that, you need to be agnostic. So here's Vault as an option. All right, so with Vault, one of the key things that I did want to point out was the data encryption. So if you, I don't know if everybody is familiar with Hashi Learn for Vault. They actually have and it's in the resource section on those slides. There's a way that you can go in and set up a vault, run vault locally on your box, and then play with it. Now, when you do this, when you do set up Vault, you need to understand on your local system, on your laptop, that Vault is holding your key value and your secrets in memory. And I don't want people to I want people to understand that when you're running it in the dev environment, is being held in memory, and you can actually query that memory and see it. So that's just something to keep in mind when you're talking about using Vault if you're just doing it in a dev environment. When I say dev environment, you'll run Vault server -dev. But if you want Vault server and you're using Vault and not in the dev, it's still held in memory, but again, that Vault cluster is sitting out somewhere on your AWS or some account, and hopefully you're encrypting your actual well, I don't want to say your data source, but your root volumes. It's just something to keep aware of when we're talking about Vault. And I should probably, I may have time to show that. All right, so let's go here. We did Vault. All right, preparing for the exam. So this is super huge here. Let me go over here, and I'm gonna walk you through some stuff. Terraform, no, yeah, Terraform Exam. So the Terraform Exam guide. I'm gonna show you my thoughts on how to study for this and point out some very key things. How am I looking on time? We're supposed to stop at 12, correct?
If we go over, I have no heartache. And
Okay.
if people can't stay the whole time, they can always watch the video, watch it on YouTube. So if you go beyond 12, I won't cry.
Okay. So this is the section where I think everybody should start taking notes, or you can come back and watch the video. I know most people won't sit through a 2-hour video, so you might as well take notes. My preference. All right. So I kind of hopped around a bit, but I was going actually off of this exam guide. So as you can see in this exam guide, they immediately start talking about infrastructure as code. They immediately also start talking about describing the advantages of infrastructure as code. There's a video, but you can honestly think to yourself, what is the advantage of having your infrastructure defined as code? One of the big key advantages of defining your infrastructure as code is you actually get a chance to write out. For me, the thought process of writing out what you want to have defined. The other one is being able to take that knowledge out of my head and being able to share it, which means I'm writing that down, which means I'm checking that code into some type of version control, meaning I'm able to share with my team what I have defined and what I want my infrastructure to look like. So this is super important when we're talking about how do we scale as a team. Super important when we're talking about, hey, I want to go on vacation versus I logged into AWS, I spun up 50 instances, and oh, by the way, I didn't give them any tags at all. So, I don't know what's out there. And by the way, it's under my account. It's not under a team account, so you have no idea what's out there. So again, we're talking about describing infrastructure as code. Always think of when you're doing, for me, when you're doing any work, always think of things as, I'm going to share this out with someone. I am on a team. I am going to define this. I am going to scale this. That's always my thought process and pattern. So when you get into that being a ritual and a habit, you're going to always say, okay, well, how do I write this infrastructure down as code? What am I trying to achieve? Who am I sharing this with? And what does that look like? So this multi-cloud deployment, super important. There's a talk from IBM on what is a multi-cloud strategy and what is a hybrid cloud strategy. One of the big things, I don't know if you all are familiar with the one of the outages from Netflix. I don't know. This was probably like, I don't know, probably I want to say 2010 maybe. I think it was when Netflix went down on AWS. Everything went down. They had a big outage, and they recently had an outage as well too. But they had a big outage on AWS. And now let's just let's just play that game. I have a outage on AWS. My entire infrastructure lives on AWS. I'm a big company, and I go out. Of course, there's somebody's gonna some heads may possibly roll because we're talking money here. However, just think if I had a multi-cloud strategy where if I did fail in one cloud, I should be able to be spun up, or at least the two clouds can actually be talking to each other. One of the big things then is, well, how do I define my infrastructure that's over here in AWS and my infrastructure that may be over here in Google Cloud or in Azure or wherever you choose? So how do I define, what can I use to define that? Well, of course I can use CloudFormation over here in AWS, and then I can come over here and use Azure templates. But guess what? I have a team, and that's gonna now say, well, what does this team need to know? Well, they need to know how to use CloudFormation, and they need to know how to use Azure, and how to define that. But maybe I don't have that a big enough team, or maybe I don't have people on my team that know that. So that one, the scale up and the time to learn and so forth is a problem. So another reason why you should use Terraform is because now at least I can, and throwing words out here, I can go to Terraform and look at the providers that they offer and say, well, I want to use Azure or Google Cloud here. Well, I want to use Google Cloud here. I mean, AWS here, and I want to use Azure here. But I have one particular HashiCorp language. I have one particular tool that I can use in order to get me the most bang for my buck. Then we start talking about state, and I'm going to go into this a little bit more in later slides, but let's for now, let me just go over this, and then I'll go back to my slides. All right, so Terraform state. Let me pull this up. Well, let me talk about it, and then I'll pull this up. No, Zoom didn't go down. Somebody's having problems, but okay. But for Terraform state, let's start with, when I declare my Terraform files, there are three files, and somebody asked about this earlier when we're talking about the directory structure. There are three main files that from the exam that they talk about. One is the main.tf. The second one is the output.tf, and then the other one is the vars.tf. And they're both written in HCL, which is HashiCorp Configuration Language. So let me pull that up right here. So let me get out of here. And then this is just something I was working on. This is I was doing a Rancher deployment for this actual meetup. That's what I was going to do, but I didn't get a chance to finish it off. However, we got enough meat and potatoes that we can get through this. So as you can see here is my, let me clear, give you that. Here's my actual directory.
Tameika, we can still see your web page, not what you're typing.
Ah, so I didn't share my whole thing, huh?
No, I think it only lets you share a window at a time. So you can go down and change what you're sharing. There you go.
Got it. There you go. All right. So here we have, let me go up one. I was doing, like I said, a Rancher deployment, but here's my directory that I'm in. It's called infrastructure. And you can see I have a README in here. I have my backend.tf, when this is important when we're talking about state. And then I have my main.tf and my output.tf. Like I said before, the three that you need are main.tf, just the bare three, output.tf, and then vars.tf. Okay. Main.tf is usually where you're going to define your data and your resources, as I spoke earlier. Remember, data is for infrastructure that has already been declared on the particular platform that you're deploying to. And resources are what I want to have defined and what I want Terraform to use as it queries the API of that platform in order to deploy a resource or deploy my infrastructure. So let's look at main.tf. Is this too small for everybody? Just let me know.
No, that's a good font size.
Okay, cool. All right. So as you can see here, inside my file, I have a data right here. Remember, I'm going to keep repeating myself because I want to drill it in. Data refers to a defined resource. So I've already defined a AWS S3 bucket object out there. And let's walk through this. We're saying data, which means it's already defined. Here is the actual, I don't want to say resource, but the resource that's already defined out there, and then the name. This name could be something else, but this actually has to be that particular name. Now, how do I know what this is and where this stuff comes from and what all this is? We're gonna get to that. So here's my resource, meaning that this is what I want to have placed on AWS, and I'm saying, hey, use this resource AWS instance, and then name it real image server, and then go through and build out this machine based upon what I've defined. Now, how do I know all this? You just can't figure this out on your own. It's just not, osmosis. So if we go over here to Terraform and we look up providers. Oh, and I got to switch screens again, huh?
I was going to say, I do have two questions when you have a
Go
break.
ahead.
One is, how do you see the process of architecting the solution when creating infrastructure as code?
Repeat that again?
How do you see the process of architecting a solution when creating infrastructure as code?
So that sounds like you're asking, how do I architect out my infrastructure to be deployed on some platform, correct?
I believe so.
All right. So there's a number of things that come to mind. First is, what am I architecting for? What are the requirements? What has already been done? And two, what type of security standards do I need to meet? Those are my immediate questions when I am architecting a solution for someone. What is I like? Let me give you how I look at stuff. Give me the big picture first of what you're trying to accomplish, and then take that big picture and make it modular as possible. And then let's talk about these small pieces and how we can attack them. Inclusive of all of that is always wrapping security around that, because oftentimes what I find just throughout companies, throughout just people themselves, I wrote this Terraform file, I wrote this Ansible stuff, it works. And then we say, tech debt, I need to go back and add security. Tech that it didn't work when I added security. So it's always a issue. So what I like to do is get the problem child's, up front. Let's get the problem child take care of up front, and then work through the security issues as we walk through everything. That way we have that. So that's usually my approach when I'm designing and architecting, is actually finding out what the big picture, what they're trying to accomplish. And then sometimes what they're trying to accomplish, you'll find that, it's a solution that may be already out there, or you've already written those files, and so you can kind of copy the code, which is always great. But that's my approach of that. Does that answer your question?
I will find that out in a minute. It sounds like what was being asked. The other question is kind of a two-part question.
Okay.
Do you separate, when you're creating your Terraform directory structure, Do you
Mhm.
separate your directories by AWS service under the specific app parent directory? Or do
Mhm.
you have your services at the top level? Or do you separate by environments? How do you set up Terraform Workspaces, not Enterprise Edition, uh, with respect to different environments?
Okay, so that's a great question, and let me give you my short answer. So when I'm thinking of multiple, let me clear. Let me be clear. I don't use Workspaces because I use GitLab, but let me explain why. So when we're talking about different environments, I use GitLab to define to define my environments that I want to set up, and I use branching strategy is in terms of using Git in order to define where I want my code to be deployed. So if I have, give you an example, if I have a development environment, a QA environment, a uh, a um, a production environment, I'm probably going to have that defined inside of GitLab, inside of branches. So I'm going to use the branching strategy. So that way, when I go to deploy or what have you, I'm deploying to say the dev environment, and you can then take that out and put that inside of here. So let's go back. So in here, I can do, let's do make dir, and let's put in, let's actually go up one out of this directory. And let's do make dir, and let's put in dev. Let's put in QA, and then let's put in product and prod.
We're still on your web.
Oh, I thought you were back here. Sorry.
That's all right.
So what I did was I made 3 directories here, and then I have those here, right? So if you use Workspaces, this works great. Sorry for the extra R. This works great if you have Workspaces where you can switch in between workspaces. But because I use GitLab, and let me show you exactly what I'm talking about, we can come here and let's go back over to here. All right, so inside of GitLab, I can come in here and I can create another branch, which I've already kind of defined here in my folders, and I'll walk you through that. But in here, I can define a new branch, and I can have my dev branch, I can have my QA branch, and I can have my production branch. And then down in here, when you get down to settings down here, I think it may be in general, but let me double check here. In GitLab, I can go ahead and define my environment. I think it may be in general. Let me double check. I gotta find it. But in here, inside of GitLab, I can define my environment. So basically, and inside my YAML file, which is super cool. In here, I can define where I want some code to run in a particular environment. Now, why is that important for me? The important thing for me is when I do this. Oh, did you able to see my stuff? Oh man,
We
you was
can
not able.
we see your screen with your directories. Your
Yeah,
we see your
this is
terminal.
what I was trying to show. So inside of GitLab here, I can come up, I can say, let me go over here to repository. I can define those particular directories can be defined as branches here. And so when I want to deploy something to the dev branch, which I can then tool down to a particular environment using GitLab, I'll check my code in, and I can have something that says, okay, you're going to deploy to the dev branch inside of GitLab. It's going to deploy to your development environment that you have set up inside of that. So for me, the use of workspaces, I don't use it. And the other part about using workspaces is, how do you scale your workspace, right? So this is going to that Terraform state. You would want to have, and let me make sure I switch back over. you want to have this right here inside of infrastructure. You want to have a backend.tf file, because now as I continue to grow, I'm going to have a location of where my state is being held. So what happens with Workspaces, unless you're having like, I guess it would work if you had a Bastion host out there and everybody logs into that Bastion host and you shared a workspace directory, but then you risk the chance of losing that Bastion host because that state of your infrastructure is held local or somebody hacking it. So at least out here you can do you can have your Terraform state out in an S3 bucket, defined in an S3 bucket. There's another piece to this. You can turn on encryption for this and use DynamoDB as well for your to host your state as well too. So there's two other pieces that you can do. You don't have to do it, but rule of thumb is they would like for you to have it encrypted. You would want to, and then the other piece is DynamoDB to hold your state as well too, as part of your state locking. So if I am deploying Terraform, say we got 5 people on the team, and I wanted to, we say this is the final state that we want to have. You need DynamoDB in order to lock your state. So I want to deploy, and this is what the production is going to look like, and then we can lock our state. That way, no one else can manipulate and change that. And that's kind of one of the benefits of Terraform Enterprise and Terraform Cloud. You can do policy as code, but we'll get there. Any questions so far? Did I answer that question for you?
I would say you did. He does have a follow-up.
Oh, go ahead.
When you use GitLab and you
Mm-hmm.
execute a pipeline job that does a deploy, but your Terraform apply stage fails, what happens when you rerun the job with respect to the state, plan, and locking? What if someone else also running a pipeline job and the S3 backend is shared?
Well, that's the whole point with the locking. You can it'll be locked so no one can do anything. So with the Terraform, like if I'm running something and you're running and someone else is running something, you can set it to lock after your run, and then once you get done with that, you can unlock it and then they can do their run. Usually what will happen is if they try to run something, because it's locked, it's going to fail. And so again, team communication, team slacks, team communication on what you're doing and so forth is important. And the other part, again, querying the state of what you're doing as well too. Does that make sense?
It does to me.
Did I answer your question?
I will see if he comes back.
Okay.
So go on, and if it hasn't, I'll find out in a moment.
Okay.
He said yes, thank you.
You're welcome. All right. So when I was talking about this resource here, I wanted to show you where everything was at. So again, we defined a data, then we're querying the API for what's already there. We're looking at a resource and saying, hey, we want to make this infrastructure be deployed onto AWS for this in this case, and then we're gonna say do these things. Now, what are those things, and how do I find that out? So let me go back and go over to here. All right. And we got a list of Terraform providers on the left-hand side right here. As you can see, we got AppMesh, Batch, Cloud9, so forth and so on, AWS, and now we hop down here to EC2 and so forth. So as you can see, the first thing here, you see a list of data all the way down. I don't want to call them resources because that's kind of, we say data sources. We have a list of data sources that you can use to query AWS. And then down here, we have a list of resources that we are going to use to declare. In my code, I am using AWS instance. So sorry for the quick scroll if I'm making nauseous here. So here's AWS instance. So let's jump down here real quick. This first one is the argument reference, meaning these are things that you can define inside of your main.tf file. Down here, if you keep going, the next big break line. Sorry for speeding so fast, but attribute reference. Attribute reference are your outputs. So the first one you can consider your inputs, and the attribute reference are considered your outputs. So when we're talking about what we want to have defined, if we scroll back up, you'll see there are some things that are required, and they have it right beside it. The AMI, that's required. In other words, Amazon machine image is a required thing. In other words, what AMI do you want to use? Basically, your OS that you want to use in order to deploy on AWS. If you see optional, but there's some other required things down here. Your instance type, whether it's a T2 micro, was it a T2 micro, a T2 small? There's another one. The metal, the M5 metal machine. Those things, whether it's required or not. So that's what you'll get there. Oh, sprint, awesome. Quit, great. All right, so then you come down here, you'll see more like user data, private IPs. These are things that you can define. And if you keep going, boom, boom, right here, these are the outputs that you can get based upon what you have defined. ID is most definitely, you can get the ID. You'll get the public DNS, the public IP, the private DNS, private IP, security groups. So those security groups, if you don't define a security group, AWS will make a default security group for you. You could do that even from when you're logging in and launching, you'll get that. So these are some of the things that you get when you're talking about defining when you're using a provider. So let's actually walk through some stuff. Let me go back to my screen.
Before you get to that, I've got the Terraform backend can't take variables. If you're relying on Git branches for distinction between dev and prod, then how do you create distinct state for dev and prod?
With the buckets, with the backends, with that backend file.
Okay.
Yeah. So
Hopefully
if you did,
that answers the question. If not,
okay.
Put it in chat.
Yeah. So yeah. So am I not on here? There we go. So right here, when I was saying the different backend file, your backend file is here. So you can, inside your backend file, you can declare whatever bucket that you want to have that state stored in for that environment. That way you can keep it separate. That way you know where it's at. Like I could say, I can come in here and I could say, I can name this, I can have it all in one bucket. I can have this particular bucket, and then I can say, well, dev, and then put Terraform state. Then I can have production, and then put the Terraform state. I can have all that there. That wouldn't necessarily, that's not a variable. That is actually a Terraform file, and that environment would know to look in that. When you go to deploy, it would know to look in that particular bucket for the state for that environment. So that's how you can separate the two, and you can again use your branching strategy for that, because it'll be defined in that particular branch if you want it to. All right. So the other piece to this is that I want to show you was my vars.tf. So here is where I put everything, my variables, what I want to have with sizing, the subnets, the VPC I want to deploy in, my security groups, and so forth. That's, again, part of those three main files: the output, the main.tf, and then the vars.tf. And I'm showing you the vars. And I kept my output really simple. I'm just playing around. Hey, grab me the region, grab me the metal IP, and grab me the public DNS. Let's walk through this real quick. Output is what it sounds like. Output. That's how you're saying. Give me that output. This name could be any name you want. You could call this Meetup Nova, Linux Lug, whatever you want. But this is the meat and the potatoes. You're declaring here. You're saying this is the resource that I want output from, which in this case was AWS instance. This is the name that I have defined inside of my main.tf, the name of that resource. And here, remember that attribute reference. And when I say inputs and outputs, this is where the output comes into play. Here's my private, my private underscore IP or my public DNS. These are the outputs that I can get more outputs that I want, but these are just the outputs that I want for now.
And I'm going to be pedantic and say this, but you have your metal public IP outputting the private IP.
Yeah, I know. I told you I didn't finish up. Yeah.
But my real question is, your instance is being created called rel image server. What if you're creating multiple instances?
Yep, that's count.
Same thing.
Oh, so that's count, and then that is a count index.
Right. So how would that work in that in the output file? Because you just have the single name, or would it automatically pick up the other stuff?
No, it's called splat. Let me show you a splat. Actually, let me show you a splat. Let me get back to my GitLab.
I love IT terms.
Hey, let me show you a splat. Let me go to my projects because I don't have one defined in here, but here's a splat right here. This is a splat.
We see the other screen with your.
Oh, sorry.
And that one question he did, that was the answer he was looking for.
Right. So this is a splat right here. So basically the splat is a for loop. Instead of you for looping through this to grab that output. So in this came out in .12. You can now take this output and it's going to give you this output in a output form, in a for loop form. It's just going to boom, 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 give you your output. So you don't have to write. You can put in 10. You want 10 output. You want the 10 output variables of X, Y, and Z, and it's going to just go for loop and spit that out to the screen. I think I have a view of that. Let me go in here to pipelines. And let's hit this one. This is going to take me to Terraform Cloud because I have this set up on Terraform Cloud. I wanted to show you all that.
I take a Terraform Cloud as a way for you to use a cloud environment to build your Terraform.
So it's a way to hold your state environment for Terraform. And we're going to get into it. But let me show you this. So here's that output right here. So that splat gave me these 3 as my output. That's what that looks like. So your output would look just like this. And this is a one I did for women in Linux to do a deployment out to DigitalOcean and how to use DigitalOcean and Terraform Cloud and GitLab together, which is what I want to show here. So you got your output 1, 2, 3, boom, and done. So that's what the splat does. So if I change my count inside my Terraform file, in my main.tf to 10, and I want to get the output for every last one of them, let me show you what that code actually looks like as well too. Go back here and show you what that code looks like, how you write it. So in here, you see this line right here. I have a tag of count.index +1. So basically what's going to happen out on DigitalOcean, it's going to have a tag of starting at 0 and going all the way up to a count of 3. And so each tag I have that. But now if I say I want to attach this index to, I want to change this name every single time this deploys, I would use count.index. Excuse me. I would do dash, put this in parentheses, dash.count count.index, and then that'll increment the actual index name of that particular DigitalOcean instance out there. So count index is your friend when you're talking about how do you name multiple instances out on your AWS or whatever platform that you're using. So that's what that is. All right, so let's get back to this Terraform state. I think I kind of beat it a lot, but since we were inside of which screen am I on now? We're still here. Okay, cool.
Yeah, your web browser.
All right, cool. That's where I want to be. All right, so inside the slides, I actually put in Terraform state, but here is where they go into the locking that I was talking about right here. Again, they was like, not all backend support locking, but they actually talk about how you can set up your backend to do locking. And here's the workspaces that you were talking about earlier with S3 remote, local. Again, if you're using workspaces locally, how do you scale that? And then with console, and then again, remote, some remote location, but S3 most definitely is one of the big ones. And then I don't know, has anybody ever looked at a state file? Have you ever looked at what a state file looks like or whatnot?
I have, unfortunately, just out of curiosity.
You said you haven't, or you have?
I have, just out of
okay.
I've even modified one every now and then.
Yeah, you can modify your state file and then push it back up, and then do whatever you want to at that point. But that's super important as well. And before earlier, I was talking about providers. This is, again, to say the list of providers. They give you a whole list of providers if you want to walk through and understand what providers are. And I'm skipping around because on that link that we talked about provision, on that Terraform exam, they're going to talk about provisioners. So they say use provisioners as a last resort. I'm going to pull up my screen now so you can see exactly what we're talking about when we're talking about provisioners. So we can stay here. We can stay here because I actually have the code uploaded in GitLab. So let me go over here to GitLab and let's go look at infrastructure and then main.tf. So if we scroll down here, you'll see that I have a provisioner here. Why am I highlighting this? This is being highlighted for this reason. If I want to deploy my code, my infrastructure, and then I want to use something like a Puppet or Ansible or Chef, I could use what we call a provisioner called remote exec. There's also a local exec, and let me explain the difference between the two. All right, remote exec says this: build my infrastructure, and as it comes online, connect in, and then run the actual script or playbook on the resource. So in other words, I am going to log in and do something on that particular resource. That's remote exec. Local exec says, hey, wherever I am running from, in other words, 9 times out of 10, the machine that has Terraform on it, I am going to use the local exec. I am going to run the script from here onto that machine. In other words, I'm going to act upon it. I'm going to do something. I'm going to log in and do something on it versus the remote exec, meaning I logged into the machine and then I'm running something. Is that clear? Because when I run something on that machine, in other words, using remote exec, the machine is up. It doesn't have Terraform on it. Local exec is I am running from here, locally, and that machine has Terraform, and then I'm going to do something on that machine. There's a key distinct difference between the two. And the biggest difference between the two is this. because it takes time in order for your machine to get initialized and actually come up, and SSH comes online, or the machine comes online and SSH is ready, available, the port is actually running. What most people try to do is they'll do a cheat, and this cheat is to use remote exec and then just echo something out. So basically what will happen is it will log in, and because you're logging in as EC2 user, you're going to have this host file sitting in that directory. But what they did was it let you know that the actual machine is up. And then what most people do next is they'll run a local exec, because they have an Ansible playbook that they don't want to have transferred over to that particular machine. They just want the Ansible playbook to act upon that machine and do exactly what it needs to do. That's the major difference between remote and local that you'll find. And those are provisioners for Terraform. They say use them as a last resort, but that's just how you use it for when you're using Ansible, Puppet, or Chef, or Salt, or something of that nature, and you don't want to wait till the machine comes up. And I'll show you what I'm talking about. So I don't have my Ansible code sitting in here, and I'll show you another repository where I do have that at. I have inside my GitLab file. Basically, I'm coming in here, I'm a provision an instance, and then you see down here, I have this Ansible playbook running outside of my build of my infrastructure. So there's two ways you can do it. You can say, hey, once this machine spins up, everything I want to happen to that machine, already have it done. Or you can say, spin the machine up, but you got to remember, once you spin that machine up, I need to grab the IP of that machine and then log in and then do some things, versus inside the remote exec, I'm already there, do what I tell you to do. So that's one of the major differences. Is there any questions on that?
Not in the chat.
Okay.
If somebody wants to break in and ask.
All right, so as you see here, they got other provisioner, like the file provisioner. The file provisioner, you could use that just to transfer files. So say you have something local to your local to whatever wherever your environment is, and then transfer that file over. So that's a quick way to transfer files if you don't want to use something like Ansible or Puppet or something of that nature. But they also have a Puppet provisioner, and then also have a Salt masterless provisioner. I have not played with Salt and Chef. I haven't played with Habitat either. I played with the file and the Puppet and remote and local exec. So let's see, what else do they have? Oh, backends. I went over that. Modules. All right, so let's talk about some things here. Is anybody familiar with creating modules and doing releases, and also doing creating modules, releases, and then having them used by the masses in Terraform registry? So there's some key things here, and let's go here. I actually have these in the slide. Let me go back to that slide real quick, because we did, well, I'll talk about the workflow in a minute, but let's go here. Backends. Where is my registry? Right here. It's what I want. Terraform registry. So when you are building your, say, a module for the entire company to use, or a big team or whatnot, you don't necessarily want to use what Terraform has already defined, especially if you're doing something enterprise-wide. You probably want to start hopping on and using modules. And the reason for that is because you're going to start using, more like a template style. Like, we have this set of modules that we have this set of code that's going to deploy out to Azure or Google Cloud, and this is the template that we want you to follow. So you may have a certain set of resources or what have you. But what ends up happening is when you're using modules, you want to keep those stored, one, in version control. Two, you also want to have some type of release strategy when you're talking about your modules, because you may update them, you may make some changes or whatnot. So you want to have some type of release strategy when you're talking about, hey, version 1, version 2, version 3, release notes, those type of things. So from the perspective of Hashi actually, all the code lives out in GitHub. And what they do is, if I don't know if you ever looked at a Terraform registry module, let's go look at Terraform registry module. Let's look at Terraform, and you'll see what I'm talking about right here. And I put an example inside the code, but let's just look at AWS S3. That's fine. Search. All right, here we go. All right, so if you look at this, and if you ever looked at their GitHub repo for Terraform, and walk through it now, I put those in the slide. I put that in the slide too. You'll see you'll have the README, the inputs, the outputs, the dependency, and the resources. And the other one that you gotta have is examples. So when you create a Terraform module, and you're gonna submit this for approval for up to Terraform, up to Hashi, these are the requirements that you gotta have. You need to have a README, you need to have inputs, you need to have outputs, you need to have resources. Those, I think the dependencies will automatically come up, but I think you need to define those, and then examples. And there's a directory structure that you must follow in order to in order to do this as well. And they kind of define that. Well, here's the Terraform code. Here's their directory. I mean, their GitHub repo. But here is an example of what I'm talking about here, where they go in and they have their module, and you're defining down here like the name. The key here is this source. This source is like where does this module code live? So if you're using this inside of your main.tf, you're going to need to define where does that code live in order to be used. Now, one thing I didn't really fully discuss, and let me hop back over to another screen because this goes along with Terraform code here. And I'm in my file, I'm in my infrastructure folder here. And before I talked about workflow, but I kind of skipped over some stuff there. So when I like to do my workflow like this. And let me pull that up so I make sure that you all can see that. And we'll go through that workflow. Terraform, they actually like to, like I said before, they say do write, plan, and apply. I like to, for my flow, I like to do write, format, validate, plan, and apply. What I should be doing is write, format, Terraform lint, validate, plan, test my code. As actually the testing comes before the plan, and then apply. So reason why I say that is we don't do enough testing when it comes to testing out our infrastructure. So TerraTest allows me to say, hey, go deploy this particular code block and make sure I'm getting the right inputs and outputs together. And if I fail, then I know my plan and apply is going to fail. Seems kind of redundant, but this allows for you to do other testing like, hey, I'm going to deploy my infrastructure, but also I want to test to see if once this gets deployed, am I going to be able to communicate to the database? Am I going to be able to communicate to a web server? Am I going to be able to walk, do what I say I have defined and have the ability to do? So basically I can start injecting testing and security into my infrastructure and my workflow. So really what should have happened was it should have been Terraform, test, and then plan, and then apply. So that's out of order. I apologize. But that's I don't know if everyone is familiar with Terra test. I actually have some code for Terra test, but here we go. We'll go here. And this isn't on the exam, but I just want you to be aware of it, of how Terra test works. And they got an example on it for let's see, quick start examples. Yeah. All right. So here, when I say code blocks, this is what I was talking about right here. Like this function right here, if I have like 4 of these functions in here, what's going to happen is Terraform is going to what is going to happen is it's going to deploy the infrastructure in each function. So it's going to go out, it's going to initialize, it's going to plan and apply. And the reason why I say plan and apply, because you don't see plan right here, but by default, whenever you do an apply, you're also doing a plan too. It also actually runs a hidden plan under that. So what happens with this is I specify the directory of where my infrastructure is. And then after I specify my directory of where my Terraform file is, let me clarify that, my .tf files, it's going to read that directory and it's going to do every single thing that you've gotten inside that main.tf file. And it's going to do the output and everything that you have defined. But in here, as you can see, I defined some output that I want to receive from Terraform, and then assert, meaning like, does the output equal to hello world? If the output equals to hello world, great. Do these two match? Yes. Okay, then I know that I've tested it. And they actually have an example on how to do one with a hello world example and so forth, like if you want to test a web server. And on the side here, they walk through and they tell you about what each piece means. Again, the directory, you drop down here to 2. You're going to do an init and apply, and it says if there's any errors, it'll fail. So that way you know that your code is going to fail as well. If when you run that before you get to a plan or apply. And then 3, again, we want to get some output. And 4, destroy. And so it's going to spin up and tear down your infrastructure, spin up and tear down your infrastructure. And yes, it does spin up and tear down your infrastructure. And if you have a backend defined, your state, it's going to update that state every single time it does this. So be aware of that when you're doing this as well, because it can go through and say, okay, hey, you got something out there that you want to have. If you don't want to have destroyed, that's when you can go into your Terraform state, pull that out of the actual, download that state file, pull it out of your state file, re-upload your state file, and then run your Terraform apply and the plan if you don't want that destroyed. That's just a FYI. Take it from me. I destroyed my own infrastructure a couple of times. So, all right, back to the registry here.
I do have a question. Are the hotkeys for formatting? Oh, never mind. That's a different question. He's asking. Okay. He initially asked if you use your editor to quickly format your Terraform files, like Prettify, etc. And I replied that, yeah, you pretty much have to, or things can get ugly.
Mm-hmm.
And he had asked about hotkeys. So.
Okay.
But that has not to do with what you're talking about.
All right. So the other thing to note here is you can see right here how these are set up in terms of like the names and so forth, those are your inputs. If you scroll up here, these are your inputs. You'll see, if I just do a look for name, you'll see there's a name and you're defining what that is. If it's a string or a number or a map or a list, you define those things. That's what you have here. If we go back, you'll see these are outputs. These are the outputs that you were saying that you're going to get. You actually have these defined in that output file, that output.tf file. And then the resources, it's going to read whether or not you have those resources that you have defined in your main.tf file. It's going to look for that and define that. So again, remember, when you check in your code, you're going to have to create a release. You're going to need an example. And they have, you know, the list of examples on how to use your module, your outputs, your inputs, and your README. And I think you don't have to define the dependency. I think it defines the dependency for you. And then if you come up here, you'll see there's different releases of this. So if you were going to use, say, Terraform registry and you want to use version 3.4, you can define that version for auto scaling inside your code as a, you know, for use this module for auto scaling, but use version 3.4, you can define that. So that's just something to keep in mind when we're talking about Terraform registry, how to use modules on an enterprise level, and then also how to use modules on an enterprise level, and also how to create and set up your modules and create your strategy. And you can see over here where they talk about provision instructions, like see how they have the version specified. You can change that version and the source of where that comes from, and then start using this auto scale module. Say you upgraded something but you need to use version 3.4 because 3.5 there's some differences. You can always use the module and revert back to using the 3.4 if you had to. All right, so that's Terraform registry. Again, they go over that here. Again, the tags, you have to have that, a description and so forth, and examples. That's one of the things. All right, so let's go back over to here. We went over Terraform tests. We went through that. We went over modules, went over registry. Let's go to Terraform Cloud, and then I think we got time for a demo. So let's go hit up Terraform Cloud.
Tameika, we always have time for a demo.
I was getting ready to type demo when you said it, and I should be typing Terraform Cloud. And I'm gonna make sure I went back over everything from the perspective of the exam. All right, so how did I get here? You see, I got a trial version. It expires in 2 days. Let's talk about this because this is actually part of the exam guide. So Terraform cloud pricing and understanding the difference. Let me see, do they have it? Can I get to it without being logged in? Maybe. Yeah. All right. Cool. All right. So again, they say open source version. In other words, that's your backend that you want. But they have a download here for this looks like this is just Terraform. Oh yeah, it's Terraform Cloud. Yeah, that's just Terraform. See, yeah, it's logging me in. Let me just log out. And let's go here. And let's see if it keeps me logged out. Keep going. Here we go. Compare offerings. Right here. All right. So you can sign up and get your free account for up to 5 users. Key things that you don't get are listed down here. Console, not console, but roles and team management and Sentinel. Okay, Sentinel is what we consider creating a policy or compliance as code. All right. So with Sentinel inside of Terraform Enterprise and Terraform Cloud, what it allows me to do is say, I check my code into GitLab. GitLab has now set up a webhook between GitLab and Terraform. GitLab, I check my code in, it's gonna, the CI runner is gonna kick off a pipeline. Since my Terraform, since GitLab is connected to Terraform Enterprise, it's gonna pull, it's gonna walk through the steps, and I'll show it to you. It's gonna walk through the steps of that code. And because I have defined something in a policy for using Sentinel that says, if you do not have tags in on your instances, you cannot deploy, it'll stop. I can also set it up and say, well, you don't have permissions to deploy to that environment. So you can write policy around using Sentinel around your infrastructure before it gets applied to your platform. Here they're showing each one what you gain. At $20 a month, you gain you already had the private module registry, but you gain the roles. Then the Sentinel. I think I have this version here. I don't get cost estimation when I use DigitalOcean. I get it when I use AWS. I'm not sure about the Azure piece. I may get that doing Azure piece. I'm not sure. And then of course, this is the enterprise version. Again, key here is self-hosted on your private network. So let's log in to here and see what it looks like. Where's the login? Sign in. I think that's it right there. All right. So once you have your webhook set up from GitLab to Terraform Enterprise, you'll come in here and I say I want to create a new workspace. So what you see here is I've already connected to gitlab.com. I can connect to a different BCS. But now that I've connected to here, I can click on that. And what it does, it goes out to gitlab.com and it pulls in all my repos that I have set up here. So I have a repo set up for this particular meetup. It's not going to work, and I'll tell you why in a minute. So now I'm going to create the workspace. So now it's doing this thing, it's talking, blah, blah, blah. All right, why won't it work automatically? Let me flip to the other screen. I'll tell you why. So it won't work automatically because it's looking for the .tf files when you're setting up your workspace. So it says, hey, you got this workspace set up, but I don't see any .tf files. Well, my .tf files are in a folder called infrastructure. So once it does its thing, I have to go back over to here. I'm not configuring any variables right now. Let's go state, nothing, variables, settings. And I want to say it's under general. The directory is infrastructure. And I'm going to save that. So it's going to find that. So now it knows where it's at. I choose to have a remote state. I also, I could do auto apply or manual apply, meaning don't deploy without my approval. So we'll do auto apply here. And then you get to choose what version of Terraform you want to run, .12, .28, .27, and so forth. And then here, let's save your settings. All right, so settings are saved. So now what does that actually mean, Tameika? All right, we run back over here. We can queue the plan or I can configure some variables. So we have order of preference of precedence when we're talking about variables. You can have variables set at the environment level. You can have variables set in the vars file. You can have variables set in a file. You can have variables set in the .tf file. So there's an order in which that happens, an order of precedence which that happens, and that's out on the exam guide, and I'll get to that. But I wanted to show you this part. I wanted to also show you where it says there's no state right here because I haven't ran anything and we don't have any runs, even though there are runs that I did out in GitLab. It didn't import those runs into here because it doesn't know about that state for that. So basically what can happen is I can go to my infrastructure folder here, and let's move backend.tf to backend.org, right? And clear. And I'm on the screen. I'll get there in a minute. I'm just gonna do a push of this code real quick, and then we'll see some stuff happening inside the terminal. I'm doing a git add, and then I'm gonna do a git commit, and then a git push. All right, so I submitted my code. If we'll hop over here to GitLab, my little screens, my little mini screens is killing me right now. Here we go. And then we hop down here. I'm gonna go to pipelines.
Nope, still see your terminal.
Oh, I thought it changed. All right, so
GitLab.
all right, you see GitLab is running here, setting up the host, so forth and so on. So let's go back over here to Terraform Cloud. Let's do a refresh here. Should have picked up. No, it didn't. That's awesome. Let's see what happened.
Gotta love a good demo.
Let's see what happened. Let me see. Yeah, it's still pulling here. So let's cancel that. Do I need to queue the plan? Sure. All right. Shouldn't have to do that. All right, it's running it manually. I shouldn't have to do that. I should have been able to check my code in. Once I check my code in, it should automatically do its thing. I just canceled what I just did, so it's gonna run everything here. So you'll see everything that pops up here. Oh, we have an error. Let's see what we're talking about. All right, that's fine. Let's go over here to the code and get rid of those. I know exactly what those are. Share. Not that one. Vars.tf. And you're complaining about these. We don't need them. Git add. Git commit. Removed. Vars. Git push. All right. So let's just see if it actually picked up this run. No, it didn't. That's interesting that it didn't pick that run up. Because it should have.
We're still on your terminal.
Oh, my bad. Yeah, it didn't pick up that run. It should have picked up that run. Oh, there it is. Okay, I knew it wasn't crazy. All right, so you can see it's going through the planning phase.
That makes one of us in the room.
Again, walking through the steps. Terraform initialize. In other words, download the providers. Oh yeah, it doesn't like that. Oh, because I'm running it from here. That's fine. Anyway, I'll desync it. Anyway, it does the initialize, download the providers. Once you download the providers, and stored locally on your in your environment as .terraform, and then does your plan, talks to your backend, your state, or wherever you have your state at, creates that .terraform, the terraform.tf state file, and then once you hit apply, update the state with what you're having. So in here, this is where I was talking about. It does the cost, it'll do a policy check, and then apply, depending on what your policy says, you'll do your initial apply and so forth. So let me pull this out here so we can actually see this actually run. So I'm not destroying I'm just destroying the connection because it doesn't recognize my information. Now I'm gonna show you why it doesn't recognize that. So because that state is being held there, I'm not sure if everyone is familiar with GitLab, but what happens is in my files, inside my infrastructure folder in my main.tf, it's going to look for this locally to my box, to my box, meaning locally to my Docker container that is a runner out on AWS. And so it's going to look for that information to log in and do this information here. If I wanted to make everything work, I would just comment that out and we wouldn't have that problem. But I didn't want to do that. So let's talk about what this actually is going to do. What it's set up for. Is everybody familiar with YAML and GitLab, or maybe use Concourse or something? But anyway, long story short, what I'm doing here is I'm walking through and I'm pulling down a Docker container. This Docker container is me. In other words, I'm this I'm treating this Docker container as if I am the person sitting there typing, communicating to whatever platform that I want. And then as I walk through this, I am going to go out and say, okay, before you run any of these stages right here, I want you to set up my communication to AWS and do whatever I tell you to do. And then come down here and download an ISO and move that over to temp if I want to. And then provision me an EC2 instance and walk through the steps of Terraform and Net, apply, auto approve, save the output of the instance name, run this Ansible script, and then walk through the stages that I have defined here. And that's what you're doing here. And at the end of all of that, tear everything down. Because why? I created an AMI out of this, so I don't need to run this. So this is a way to create an AMI machine image with everything that you want. You can also use Packer. You can use AWS API with CLI, or you can use Terraform has code in there where you can use Terraform code in order to create it, to create your AMI if you wanted to. So there's several ways to create an AMI. You can use Packer to do it, or you can use Terraform to create the AMI as well too. But it'll make the AMI based upon the image that's spun up. So if you spin up an image and then say create an AMI, it's going to create an AMI based upon the image that's spun up by you. All right, so let's do this. I know that this is not going to work, so let's check that code out there. And that is in the .gitlab file. Hold on, I'm checking out. I'm going to hop back to the screen in a minute. I know you probably can't see. Any questions? I know we're getting close on time there.
None in the chat at the moment.
All right. All right, so I'm committing code and we're gonna hop onto the pipeline over there on the left-hand side under CI/CD. And let's do a git push. Boom. All right. So now we have our code. We're doing our thing, set up the host. Let's look at that. So you can see it's downloading that Docker container, downloads that Docker container. Now in that Docker container, we should talk about that. Inside that Docker container is everything that I may have on my laptop in terms of the Terraform binary, the console binary, the Vault binary, any of those things. And then I push all that stuff onto that Docker container. And so that Docker container has all the tools that I would have on that I would need to act upon and do something on that particular machine or act upon a machine. So that's super cool. And inside of GitLab, I don't know if you all are familiar with this, you can create, you can use GitLab to have your own Docker registry. So inside of GitLab, I can push and pull Docker containers up here. Let me show you one where I know has a Docker container sitting in it. Here we go, right here. So I have several different versions of a Docker container here that I've done and played with. Let's go back to the project and see where we're at on our run. And then we look at what I have on the slides and make sure I covered everything for everybody. All right, so we went through, we went through the cloud, we went through the registry, the modules, the workspaces. I talked about the flow. This is just an example. I think you kind of beat that to death on main.tf, output.tf, vars.tf. Here is a resource, here's a data, here's the output, here's vars.tf. This right here is just to show what the major differences are between CloudFormation, Terraform, and so forth. Again, when we're talking about mutable infrastructure versus immutable infrastructure, configuration management, you can get a state from Ansible. I forget what the name of that. It's a plugin that you can use. So Ansible can technically hold state, CloudFormation can't, and then of course Terraform can. And then they say cloud, but they should say different. I guess you could say providers that it can use, and then what the code, if it's open source, but also what the code is written in. So Terraform is written in Hashi configuration language. CloudFormation is written in JSON or YAML. Salt, I forget what Salt is written in. I don't know, is Salt a Ruby product or not? I can't remember.
Salt is Python.
Python, okay. Ansible is Python, and then Puppet and Chef are both Ruby. So if depending on your flavor and what you like, you can choose either or. Let's go back over here to this run real quick. All right, so you can see some stuff going on here. You can see where I'm setting up my AWS account information on the Docker container. And I also turned around and now can query my information off that Docker container. Now, what happens is you're like, oh, Tameika, you downloaded that to the Docker container. How unsecure is that? Well, this Docker container is only as good as this run. It goes back to the same state with every new stage. So whatever I want to keep to each state, we have to do what we call artifacts and carry those from stage to stage. So I want to show like, hey, here's something that I've downloaded. Here's what I did. Boom, we see the job has succeeded. So we go back over to the pipelines. We're at the next stage here. And you can see now where we did that Terraform init, Terraform plan, and Terraform apply down here. And it's now, it is querying a backend that I don't have provided because I got rid of it. So that state is sitting on that Docker container, which is horrible because now somebody needs to go behind me and actually know what I did. So, you can add that back in. I was showing y'all something and then I didn't leave it in there. So now here's a Terraform plan. one key thing to note here is everything that's a plus in the green, meaning it's going to be created. If it's a minus, it would be taken away. It would be red. And if it's a tilde, a tilde, that means it'll be replaced. And that usually shows up in orange. And it'll tell you what is going out there to build. I'm building a M5 metal machine, and I'll tell you why in a minute. And then I'm attaching a key name, and then I'm applying some tags to it, and then subnet that I want that to be in, and so forth. And then the metal machine is going to take a minute to build. All right, so why did I choose a metal machine to build? Well, one of the projects that I was working on, in order to build a OVA, and I need to have a hypervisor installed on that machine. That hypervisor needs to be able to talk back and forth in order to build a VMware OVA. So you can use Packer and install Packer onto your machine, build an OVA, build a Vagrant box, build a ISO, build a AMI and Azure and all that, and set up a pipeline to do every last one of those things. So that was one of the projects that I was working on. It was to build a pipeline to build out machine images for everything that all look the same when we go do a deployment involving a multi-cloud strategy. So when you start talking about how do you hold your state in your workspaces, well, I need to have my state, somewhere where, I can get to it from all those different clouds. Does that make sense?
Yep, it does.
Okay.
We do have a comment,
Mm-hmm.
and I hope it's meant to be public like this. The person who wrote it is our resident Red Hat employee, so
Mm-hmm.
not sure if I agree with the Ansible column in your.
Mm-hmm. That wasn't mine. That was, I found it off the internet, but go ahead.
Ansible does do state, but it doesn't store it. You declare a desired state, and Ansible will, on every run, verify the state, and if needed, correct it to match the desired state.
Gotcha.
In addition, AWS is a server component to Ansible. Not that he's claiming it's the same as Terraform in this demo regard, but there is a lot of overlap.
There's a lot about what now?
Overlap.
Oh, yeah. Well, like I say, CloudFormation doesn't have a state that you can hold, but you can most definitely query AWS for what's deployed via API. But yeah, you are right about the Ansible in terms of the state. That, like I said, I didn't know how Ansible used state because I don't hardly ever see it written out anywhere. So if you can post an example of that, that'd be great. That way I can actually share that with the rest of my team members in class and stuff like that. That'd be great. So this is going to take a minute to do its thing. Let me double verify that we went over everything for the exam in terms of that I might have missed. I know I didn't go into Vault, but I think I covered a lot. So we talked about infrastructure as code, multi-cloud, providers, provisioners. I did not talk about format. Someone did ask about import. All right, so Terraform import. So you have you have a set of infrastructure already deployed, but you never had the state of that, and it's out in some platform somewhere. So you could use, it's called Terraformer and Terraform import. I hope I spelled that right. Yeah. I think this is it. Yep, Terraformer. And put it in the chat. Do I have a chat? Yeah, right here. Yep. All right. And then in terms of the Terraformer, so what a Terraformer can, and they got an example down here of how to use it. it'll go out and grab and create a state file for you. You can take that state file and then use Terraform import to import it in. But you'll have to make when you do import, you have to declare what that resource is. So you have to go in, and it's just dummy code. You go in and you declare that resource, and then once you declare that particular resource inside your main.tf, it'll then update the state, and now you have the state of that actual that the state of what's deployed out there using Terraform import and Terraform, where you can do that. And there's another one out here that actually like Terraform graph, and where it graphs out and it does modules of like how everything is deployed and connected. It'll go out and do a graph of that as well too, if you wanted to. There's another piece that gets on it, and I think it's on this page. But you can also then use Terraform graph inside of Terraform as part of Terraform in order to graph out and see how things are connected and what variables are defined and how they communicate with each other. Let me see. And we went over, I didn't want to click on that. We went over workspaces. I didn't do Terraform debugging, but it's called TF_log is the environment variable. And then you can set it to warn, debug, trace. Trace is for verbose. Like it's gonna go through and give you a lot of information more than debugging. So you can set TF_log as an environment variable, and then set that equal to debug, trace, or what have you, whatever you choose, and then it'll give you the information that you want. We talked about modules. I did not talk about child modules. We did talk about input variables and outputs. We went over some modules. We talked about the workflow, the Terraform initialize, the Terraform validate, plan. You know what destroy means. Backends and local backend types. Terraform refresh, in other words, update. Update. You may have some updates or something like that to your state. So do a Terraform. Something might have updated in the state, but you don't know about it. You could do a Terraform refresh, grab that information, and go from there. So and if you have outputs, it'll output information back to your screen. Vault provider, I didn't talk about. Complex types, super good to know, and I'll go over that. And then dynamic blocks, you have to look at that, because I'll have to get into that, because then there's locals and then dynamic blocks and so forth. And then we did go over module registry, Sentinel, touched on that. Terraform Cloud, went over that, and then a summary of compare the packages of Terraform Cloud. So we covered a lot off the exam guide and then some. When they're talking about complex types, this is where you get when we got that, we used that splat, we returned back a list of instances. So we have a list, we have a map, and then we have a set. I have asked before how you define a set. I don't know, because a list and a map are different. The list comes in parentheses, the map comes in it may be opposite, and the map comes in brackets. Is that opposite? I think that's opposite. I think the list is the brackets and the map is parentheses. I forget. It's one or the other. I always get them mixed up. But you could tell that's how you could tell whether it's the syntax of it is whether if it's a map or a list. I don't know what the syntax is for a set. I've asked that, and no one's ever been able to define, like, if I looked at something, how do I know that's a set? I don't know what the syntax is for a set. Just kind of like when you're looking at Python code, you know what a list is, and you know what a map is in Python. And you know what a set is, but I don't know what a set is in Terraform, and I've never seen it. And I think that's it. I think I covered everything. Let me go back over here to the deployment.
Can you throw up the certification page again, just real quick?
The exam guide or the certification?
Exam guide. I think the The list you were going down.
Oh, sorry. Let me see where that's at amongst my tabs. Let me close some tabs.
Oh no, I'm making you close tabs. I feel bad.
No, you're fine. Closing tabs. You know what? Let me do this. I think I clicked off of it. And that was my keynotes that I did last year in Amsterdam. Here you go.
Is that off of your
It's on
your YouTube page?
yeah. Yeah, I just don't know what, and I suspect a set of unique elements. Yeah, but I don't know like if it's a bracket, if it's a couple of slashes, or I don't know. I don't know how to do a set in Terraform. I just never seen that. I would like to see that defined, and
Okay.
at least an example of it.
Yeah, it's nice to have examples to go by.
Yep. Yep. And somebody mentioned about Terraform format. Yep. I do Terraform format as well too. I put that on the list.
Okay.
So it's doing this thing out there in the land of GitLab.
Yeah, somebody said, I suspect a set has unique elements like in Python.
Right. So was that good for everybody? Did I cover everything? There it is right here. So deployed my metal instance. It's got my output. Boom, done. And then this is when I was saying it was logging in and trying to connect. That's because I didn't give it the I need to go back and update the key that I was using for that. But basically, it would have logged in, ran this Ansible playbook in order to do whatever I needed to do, and then keep going down the pipeline. But we used Terraform to deploy a middle image, and we got our output and so forth. Even though this is supposed to be public IP, I think it's supposed to be public IP. I think I referenced something else. You said it was something off about my.
You said you referenced private IP.
Yeah. Okay. Yeah.
It's outputting the private IP.
Private IP should be outputting the public IP.
Yeah, the public IP is in the DNS name.
Yeah, which is that one.
Yeah.
Yep. So any questions for anybody before I stop sharing?
All right. So if there are no questions, I am going to go ahead and stop the recording so people can unmute and without worry of being on YouTube. So we'll go ahead and do that.